It seems like a novelty, a robotic diving system that looks like an adorable transformer. But Ocean 1K is able to go to depths that would kill a human diver, and it can handle delicate objects without breaking them.
So the idea was to build a robot that can imitate the human shape so that it can be your avatar as diver.
This avatar mode is made possible through a haptic system, which allows the operators to literally feel what the robot touches.
It is like if your hand is inside the computer. I mean, I have to say you're very good.
Wired spoke with Professor Usuma Khatib to understand how he and his team designed, built, and tested the robotic diver. A remotely operated vehicle, in this case an underwater ROV, is tethered to a ship and controlled by an operator. Ocean 1K was designed with archaeology in mind.
We wanted to design lightweight arms to interact with scientists. We wanted them also to be safe for their interaction with the environment. The challenge is, how can you do that?
The team tackled three main design challenges: by manual manipulation, haptic feedback, and buoyancy. The first challenge, handling delicate objects underwater, started here, with the hands.
So we decided to go for a design that uses under actuation. It was very efficient, but 3 fingers was not adapted to take all kind of different objects that we wanted. This hand has the same concept, but it has now 4 fingers, different material that is better for sticking to objects underwater. I mean, objects underwater are very slippery, and again here with one actuation you are closing the hand. It turned out that for the first design we didn't have actuation for the head. Ocean 1K can track the motion of your hands, can look left and right, up and down. If you are moving in a wide simulated environment underwater or wherever, you have difficulty doing fine manipulation without the depth information. So the stereo allows you to really feel like you see exactly where your hand is with respect to the world.
These glasses allowed researchers to see underwater in 3D.
All what you have to do is to take these glasses and place the glasses, and now you can see in stereo. So we have a visual interface, but also you need to do and to connect and feel, and that is the haptic interface.
The haptic interface allows operators to feel what the robot is doing.
I always say haptics is the most difficult thing to explain. We are using the sensors of the robot that detect the forces and the movement. So if you have an object you're pushing, you're going to feel the movement and the forces. What we do is we resolve them and send them to the top through the computer algorithm, and then we reproduce them on the side of the haptic. The haptic device is essentially a robot that is, instead of acting on the environment, is acting on your hands. And it is reproducing the same forces that are felt on the robot. The tactile information is being displayed by 6 motors on the haptic device. I would like to invite you to come and try it.
And so I'm just moving it around. It is like kind of vibrating every time it falls into like a hole.
So anything you can model mathematically, you can display haptically.
Is there any delay time? Since you guys are on the boat?
Very good question. It's not like teleoperation loop, the robot autonomous system, the haptic interface autonomous system. Each of them uses a proxy, and they are just communicating what is needed in terms of information.
Ocean 1K, the team's latest ROV, was designed to go 1,000 meters underwater, but the deeper you dive, the more pressure is exerted. In order to maintain the shape of their diver while maintaining its ability to float, the team developed 2 novel solutions.
ROVs are designed with metal. We couldn't do that. We couldn't build a robot with like thick cylinders and heavy structures, so you're going to use foam. It is essentially designed to make the robot float up to 200 meters. Now imagine we want to take this to 1,000 meters. The pressure over it is going to be huge. So the only way you can do that is by increasing the density. And if you increase the density, then you are going to have more weight. More weight means you need more volume, and you end up with huge elephant-sized robot. Fortunately, material technology developed, it's called syntactic foam, built with hollow microspheres, like glass. And when they touch each other, they are going to resist because very strong and very light, hollow.
The pressure underwater at great depths also meant sensitive electronics needed to be protected, so they developed this system.
So the arm actually is completely filled with oil. And this oil is under a pressure coming from outside through a compensator. Now inside the arms, you have the same pressure as outside the arms, and then you're safe. Oil-filled structures is very important and big challenge, and believe me, we didn't know if it will succeed.
The team tested their first prototype on the shipwreck La Lune in 2016. Between 2021 and 2022, they dove on several sites throughout the Mediterranean.
Maneuvering anywhere close to a shipwreck is very dangerous. 500 meters is not a place where anyone can go and rescue the robot. We went to Aleria. We brought a vase from the Roman time that was on the cargo. We went with the camera inside the Crispy. We were able to find some very interesting biology structures that are built by iron-eating bacteria. The biologist was surprised also to see that these are usually found more in the Atlantic, in oceans, not in the Mediterranean.
But a delay from September to February meant that the ROV sat idle for months.
Ocean 1K didn't like it at all. One of the arms was really complaining that to fix the connector, you had to disassemble the whole robot because it's inside the shoulder. With underwater, you're hiding a lot of things inside cylinders, through connectors. Like, it's very dense inside and it's all covered from outside or protected. I mean, these are prototype of the future robot. So in the future, the actual robot that will be deployed will have better integration of component, placement of component, all these things that you need to make your system easy to service.
So what's next for the future of Ocean 1K?
Operation underwater are going to be critical for the future, and I think not only for archaeology, but imagine all the structures, the pipelines, laying down the fiber that we use for communication. All these structures requires maintenance. Already we have a haptic device in the space station developed by one of my former PhD students, Francois Conti. As long as you have an internet connection, you can connect to the robot. Now imagine we can control a robot from space all the way underwater. Technically, this is feasible. There are all kind of practical issues to get to it. Thanks to the convergence of technologies from computer technology to material to maturity of the field of robotics, all together, that is finally helping robotics to move forward.